okay? So this is the electrolysis of potassium iodide solution. So remember, solution means you've got water present, an aqueous solution. So that means you've got 4 different ions present. You've got the potassium ions, K+, you've got iodide ions, which is I negative, and then you've got OH minus ions and H plus ions present. So let's see what happens here. So at your anode, you get 2 things attracted here. So you got that's your positive, so that means you've got your negative things attracted there. So you're going to have your I minus ions attracted there. You will also have your OH minus ions attracted there too. But the I minus ions work out, they kind of come out on top here. So that means you get the formation of iodine at your anode. When we look back at this picture here, girls, that's what that brown color is here. So this is your anode here. This is your positive electrode. So you get the formation of a brown color here, which is your formation of your iodine. Then at your negative electrode, girls, although potassium ions are attracted to this, they're very happy ions, they're very stable ions. So therefore, here you get what's called the splitting of water. So you get water gaining electrons to form hydrogen bubbles and also OH minus ions. Now, why we see a purple color here, girls, is because we actually have phenolphthalein indicator in this solution here, and that reacts with the OH minus ions to give a purple color. So you've got at your cathode, you've got your OH minus ions forming and your H plus bubbles forming this purple color here, and then you also get this brown color here, which is your iodine forming. So this is your first set of half equations that you have to learn off. Now, really, girls, it's just sitting down and learning them. Okay, Neil, it's something that you have to go over the day before, like your flame tests and things like that. You don't retain it very well, but it is something that has to be learnt off. Okay, well, what you get your cathode, what you got your anode, it comes up in question 4 a lot. It also comes up in separate questions itself. Now, electrolysis copper sulfate solution, our second mandatory practical here. Now, this involves active electrodes that are actively involved in the process. Okay, so we've got copper ions present here, we've got sulfate ions present here, we've got OH minus ions and H plus ions here, and we also have our copper electrodes here. So, girls, the half reactions for this is that you're losing copper at your anode and you're gaining copper at your cathode. So you actually see, sorry, I've done this wrong, haven't I? So yeah, sorry, I have to just change this here, girls. Sorry, C2 plus. Let me get the formation of copper there, excuse me. So you're losing copper at your anode and you're gaining copper at your cathode. So at your cathode, girls, you'll see it actually physically gets larger during the experiment, whereas your anode, it gets smaller and smaller and smaller. It's actually wearing away. So you're transferring copper from one electrode to the other through the solution, okay? So again, this is another set of half equations that you must learn off. Okay, your third mandatory electrolysis experiment. So there's only really 3 you have to learn off, okay? So this is sodium sulfate solution. So your ions present, girls, are sodium, sulfate, OH minus and H plus ions. Now, here, girls, your sodium and your sulfate ions are actually really stable. So what you get forming at your cathode and your anode here is actually the splitting of water happens. So again, you have to learn off your 2 half equations here. So you see on this one here, you see bubbles of oxygen forming, and here on this one, you see bubbles of hydrogen forming. So again, it's essentially just a splitting of water, so you have to learn off these 2 half equations too. And it's just the reason why this occurs is because your sodium ions and your sulfate ions are just so stable, they don't want to gain or lose electrons, so then you end up getting the splitting of water. Okay, so learn off the 2 half equations for this. Now, your fourth mandatory practical, girls, is essentially exactly the same as your sodium sulfate solution, okay? Because it is just simply the splitting of water. All right. Now, the reason why this is important, girls, is because it produces hydrogen and oxygen, 2 really important things. We'll talk about why they're important in a second. Now, the problem with water, girls, pure water is covalently bonded. It does not conduct electricity very well. So when we're doing the electrolysis of water, we have to use a special piece of equipment called the Hoffman voltammeter. I'll show you a picture of that in a second. And we have to add sulfuric acid to it to allow the conduction of electrons here. This is the Hoffman voltammeter. You've probably seen one in my room, okay? We use inert platinum electrodes, and we have to add sulfuric acid to allow for the conduction of electricity through our solution. And again, you'll notice this is exactly the same. These are the same half equations it's the same half equations. They look a little bit different, but it's essentially exactly the same as this one here. So, okay, so just learn off these half equations here, and you can give that for water as well. I've drawn them slightly differently for water, for the splitting water, but essentially they're the same as for sodium sulfate here. Okay, so just learn off one set of those, either this form of it or that form of it, and just learn those off, girls. And they are the half equations that you will give for the splitting of water. Now, why the splitting of water is so important, girls, is we get oxygen, which obviously we need for medical uses, or medical reasons, and diving and things like that. And then we also get it for hydrogen, which is a possible fuel of the future, because it's a really clean fuel. When it burns, it only gives water. Okay, so they're two important uses of oxygen and hydrogen. Now, when we're using our Hoffman voltameter, girls, you'll see that you'll get double the amount of gas on one side than you do on the other. That's because you've got H2O, 2 atoms of hydrogen compared to 1 atom of oxygen. So you get twice as much hydrogen forming here as you do oxygen. So that's often the way you can tell your cathode from your anode, okay? All right, okay. So girls, we're going to move on then to electroplating. So you might have some Argos jewelry, or you might have some ear cuffs or whatever, okay, that are what are called covered in sterling silver or coated in sterling silver, okay? They have been electroplated, and it's done for aesthetic or protective reasons, okay? Now, so the way this works, girls, is the object to be plated is placed at the cathode, the negative ion, the negative electrode, okay? And the electrolyte has to contain ions of the metal that you want to cover the object with. So if you're covering it with silver or platinum, they have to be present in the electrolyte. The anode then is a bar of the metal that you want to cover the object with. So here we go. So here is a spoon getting covered in silver, in silver. So we've got our silver bar at the anode. We've got the thing we want to plate at the cathode, and we get the transfer of silver ions onto the spoon, hence covering it in silver. Okay, so it's something that's done really for aesthetic reasons or for protective reasons as well. Okay, and it's something that, like, even if you have pure platinum jewelry, you'll probably have to get them recoated over time. So it's done. You see it particularly for jewelry. You also see it for kind of chrome on posh bikes and cars. Okay, so that's electroplating. So girls, essentially that is the electrolysis topic. So the key thing is to go away and learn those half equations. What I might do is I might post up some questions from that and my workings through those towards the end of the week. But I hope that was useful.